Hi everyone, welcome to the BI project. My name is Ayush. So today we are talking about the data model. So you might have heard me in the previous videos as well, mentioning this term called data model a lot of times. It's a very important concept to understand if you want to have a good understanding of DAX. So in this video, we are just going to deep dive into the specifics of data model and see what importance does it hold from the Power BI context and how important it is to have a good data model if you want to essentially build a good performing report, right? So going to the definition, a data model is nothing but a set of tables that are linked to each other through relationships. Now two terms stand out here. One is the tables and the other one is the relationships, right? So let's deep dive into each of these terms. So tables, as you all know, most of the data that we import in Power BI is essentially stored in the form of tables, right? And this data may be in SQL Server, which you are importing into Power BI, or it could be in Excel, it could be in Snowflake, or it could be in one of the social media streams like Facebook or Twitter. So you can directly import all of that data in the form of tables in Power BI. Right? So table is nothing but a set of rows containing data with each row divided into columns, right? So this is a straightforward concept that a table has a lot of rows and a lot of columns. The vertical entities are essentially known as the columns, whereas the horizontal entities are called the rows. And each column has a data type and it contains a single piece of information. Now to understand this, let me just go to the next page and show you how a table essentially looks like, right? So here we contains three columns: order ID and market. To give you some more context, this table basically lists all the order IDs from an e-commerce company which were returned, right? So this column here called returned says yes, for all its records, which means all of these order IDs were essentially returned, and the market column tells you which market was it returned from, right? Now, each of these three columns that we see will basically have a data type, right? So data type tells you what kind of information does each column contain. In this table, all the three columns basically have the text data type, right? Because the information that is there in each of these three columns are simple text, right? Yes, and then there is a alphanumeric kind of a term, which is again in the form of a text here, and then market is also text. But other data types that a column can have are numeric, which is nothing but a whole number, or a decimal, or dates. So the data types basically tells you what kind of operations you can carry out on those columns. For example, if there was another column just besides this, which was of the data type whole number, right? So this means you can carry out operations like summing or averaging the values in the column which is of a whole number data type or a decimal data type, which you can't of course do in the text columns, right? Because summing up all the values which are text doesn't make any sense. So the data type is very important, and in the table each column basically has an associated data type, right? So moving back to the another element of a data model, which is called a relationship. Basically a link, as it says here as well, a link between the two tables that ties them together, right? So you may ask that, why do we even need to tie the two tables together, right? So for that, let me again explain this to you a bit graphically. So let me just go to the other page, right? And I'll give you an example to show you why do we essentially need to relate multiple tables. So whenever you are creating report or any analysis, it's basically present in multiple tables, right? It's seldom that you have all the data in a single table. Most of the times it will be present in multiple tables, with each table containing different set of information, right? So to create that interactive dashboard and to create that holistic set of calculations, you basically need to pull the relevant elements from each of these tables that contain, separate information. So for in this example, we have two tables called the orders table and the returns table. So it's again an e-commerce company. So the orders table contains the list of all the orders that were ever ordered, right? Along with fields like order date, right, which basically tells you on which date the order was ordered, the ship date, right, when was it shipped, the ship mode, right, which mode was it shipped, which was a courier type, standard class, or it may be a priority courier, etc. Then it talks about the other field is basically the customer ID, which customer essentially ordered this product. So it's the store basically has a unique ID for every customer. So this column basically represents that, and then you have a customer name, right? And then there is another table which is called the returns table. This table basically enlists or contains the information of all the order IDs that were returned, right? In e-commerce, the return is a very normal thing. So the product may be defective or the customer may not have liked the product. So all those products will be returned, right? So this table captures all of the order IDs that were returned. Now, the business question is, the business leader wants to know who are the customers who are actually returning my products, right? So if you look in this table, the orders table, I do have the customer information, right? But I don't have the return information, right? I don't know whether order ID was, all these order IDs. For example, if let's just talk about this order ID, which was ordered by Chuck, right? Was it returned or not? I don't know, right? Because I don't have that information in this table, right? Whereas in the return table, I do know what all order IDs were returned, but I don't know the customer name, right? There is no column for the customer name, so I don't know which customer actually returned this particular order, right? And the business problem is that we want to know what all customers are returning the orders, which means we want to know whether all of these customers, they returned the order or not, right? This means that we will have to pull the data from the orders table. We have to pull the data from the returns table into the orders table, right? To see whether all of these customers actually returned the order or not, right? So we'll basically simply look up the order IDs, all of these order IDs in the returns table and see what all order IDs are actually present in the returns table. The ones that are present, for example, if we, let's say, look at this order, and if we were able to find this order in the returns table, this means Chuck basically is a customer who returned the product, right? So in order to do that lookup, in order to sort of pull some information from another table into a table based on some common element, which in this case is order ID, we need to relate these two tables together, right? And that relationship always happens on a common element. The common element in our case is the column called order ID, right? So we'll relate these two tables, we'll create a relationship between these two tables, and then find out what all customers basically returned the orders, right? So this is where you need to relate the table, right, in order to carry out the calculations and to build the interactions in Power BI. All right, so we'll move on to the next page. So here, this just shows an example of a data model. So how does a data model in Power BI looks like? What you see on screen is, right, these boxes are nothing. And all the, these names that you see, for example, country, region, or postal code or state, province, all of these are the columns in this table. So you don't get to see the data when you're looking at the data model, but you do get to see the table names and the different columns, right? And these lines that you see between every two table, right? For example, this line and then this line, these are called basically the relationships. So as you can see, all of these tables are related to one or the other table, and then together the set of tables related to each other through relationships basically forms a data model. So in this data model, there are 7 tables related to each other through relationships.